Good morning, everyone, and welcome to part one of the Safety Studies course. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation in this training. Please note that today's session is the first of a four-part webinar series, with part two tomorrow and parts 3 and 4 next week. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the course presentation, please use the questions box to send in any questions you might have, and I'll be dispatching those periodically to the instructors. Please note also that the handouts section of your GoToWebinar panel includes PDF copies of the course presentations for reference. With that, we will go ahead and turn things over to Cindy Yerke, who is our primary instructor for today's session. Cindy, hello. Hi, Cindy. Cindy, I think we lost your audio. Hello, Cindy? Alex, can we hear you?
Hey, Mike, can you hear me?
Yes, sir. How are you doing?
Good, thank you. I will take over until Cindy's audio problem gets straightened out. Good morning, everyone. My name is Alex Maestros with Jacobs Engineering Group. I'm happy to be here today presenting. I am the alternate presenter, I suppose, for today. Cindy and I will be trading off modules. So today will be myself until Cindy's audio gets figured out, and then tomorrow will be I'll be presenting the module, and then next week we'll alternate as well.
Alex,
we're going to start off today by going through a few. Oh, Cindy, are you back?
I apologize. I don't know why. It's kind of funny how that happens right when things start talking. Audio failed, so I'm sorry about that.
No problem.
All righty. So as Alex was indicating, he and I will be alternating between today, tomorrow, and next week on the presentations. We appreciate everybody joining us for this presentation. In fairness, this is the first time that I have done this via the web option, and so we will move through these slides. Probably what feels a bit quickly, but we're going to pause it several times throughout the presentation to review and process any questions that come across, to give you the opportunity to participate throughout the course of the program. Okay. Let's give you a little bit of information about the course and the format. So as Alex mentioned, it's myself and he who will be alternating over the course of the next couple of days. As Mike mentioned, we would please request that you enter your comments into the chat box, and those will be addressed either throughout the course, if they're appropriate, or at the end of the course presentation. Mike alluded to this and touched on this a bit, but in order to receive full credit for this as a Traffic Academy course, the attendees, all of you, must complete all 4 webinar sessions and then successfully complete an online multiple choice test within 2 weeks after the course completion. For that test, a score of 80% must be achieved in order to pass. We always like to mention, please do try to take that course within 2 weeks. There isn't much of a grace period beyond that, that you can complete the course and it is shut down. So once you receive that information through the LTAP to take the course, please do it at your earliest convenience. Each of the webinars is worth 1.5 hours of PDH or CPD credits. Certificates are typically prepared and they'll be emailed to you within 1 week of the webinar. If for some reason you don't get those certificates, please reach out to the course organizers and they will follow up with you immediately thereafter. I'm going to quickly go over the agenda and then hand it back to Mike in just a minute for some poll questions. But the agenda is up on the screen, and as we mentioned, there are 4 modules today. Obviously, we introduced ourselves, but we're going to go over an ODOT safety program overview and then some background and an overview of the Highway Safety Manual. To give a little context of how the rest of the program is going to work, we're going to alternate back and forth between some of the background material on the analysis and why we are doing things the way we're doing now, and then also with some information to help you develop and prepare the safety studies, which is the certification that you're getting today. But right now, Mike, if I could flip it back to you for a couple poll questions, we'd just like to get a feel for our audience.
Yes, thanks, Cindy. And we have launched the first poll question. What type of organization do you represent? And we'll give everybody some time to respond. And wow, the responses are arriving pretty fast. 76% have voted already. Okay, a few more seconds. All right, let's see what we've got. So Cindy and Alex, 60% of the group said consultant, 19% said ODOT or DOT, 13% said local public agency, 5% said MPO, etc., and 3% said other.
Thank you very much.
And if you'd like, we could do the second poll question.
Please go ahead and do the second.
Okay, we have launched the second poll question. What is your experience with safety studies? And you can select all that apply. And once again, we see the votes arriving. All right, a few more seconds. And let's see the results. 35% said author, 44% said safety analyst, 31% said reviewer, 21% said other, and 42% said, I'm just here to learn something new.
Well, great. We've got a great mix of folks. And what we'd love to hear from those who said other, we'd love to hear what that other means. If you want to enter that information in the chat box, we'd love to hear it. But thank you, everybody. It looks like a great representation across a good cross-section of folks that are involved in the development, review, and potentially management of projects that involve safety studies. So great. We're pretty excited to have everybody here. That helps a little bit for us to understand, as we're moving forward, and when we gives us a little context for the comments and the questions that we might receive throughout the course of the training. Alrighty.
Cindy, I think I've got the poll question stuck there, so we might need to re-share your screen if you could, just for a moment.
Sure thing. I'm going to do that, and we're going to re-share. Well, I appear to be frozen up too, so give me just a moment.
Okay.
Apparently the system's giving us difficulty. Maybe it's that crazy spring weather that we're having right now. Alrighty.
Yes.
Just one moment. So I'm going to actually expand this out, and hopefully that will give me. I'm going to stop viewing. Let's do this. Let's quickly change to presenter for just a second, and then pop back to me if that works.
We will do that.
I'm going to change it to Alex for just a moment, and then I will try to change it. And then if we could try to change that back to me momentarily.
Okay.
And I believe, Alex, you have to change the presenter back to me. All right.
Okay.
Now we're, yeah. All right. Sorry.
Thanks,
for the technical
thanks everybody for your patience. Yep.
Okay. Let's go ahead and start moving through this. All right, so what we're really here today, once we get through all of the technical difficulties, and it never fails, we're going to talk about the ODOT safety study process. In general, it involves these 5 basic steps You will go through a cycle of repeating a few of them as necessary before you get from the initial step of collecting the data to developing your plan and finalizing the report. But we're going to talk through each of these steps today. I'm going to be focusing on the front end, which will happen really once you've collected your data and you're diagnosed your crash and you're starting to diagnose your crash patterns. But let's go ahead and talk a little bit more about what our goal is for today. So hopefully by the end of, at least not today, but at the end of the whole series of modules, you will have a better understanding of what goes into a safety study, what it is and when and why it needs to be completed. We'll go through all the information that you need to include and whatever information that you need to collect in order to prepare a safety study. We'll describe how and where to obtain that information. We'll talk about evaluation of the information. We'll talk about presentation and format that'll ultimately need to go into the safety study. And we'll also talk through a few of the changes to the safety program and the safety process that came about as a result of the implementation of the Highway Safety Manual, which is a key component and a really strong basis for a lot of the analysis that ODOT now uses to support both safety studies and safety analysis throughout the project development process. Before we get in too much into the weeds, though, we're going to talk a little bit about the safety program. Obviously, the safety program uses the safety study for a lot of very important reasons, but it is a method really to provide that organized approach to identifying, analyzing, and mitigating crash patterns, and also addressing and studying the highway safety priority locations that we're pretty familiar with, their lists that ODOT develops. It's a systematic approach. A safety study really provides that systematic approach to evaluating the contributing factors to crashes and identifying strategies to address those factors and look for ways to improve our roadway system that have the greatest potential benefit for safety. A safety study allows us to estimate effectiveness of proposed countermeasures. When we have alternatives that we're going to be looking at as far as potential future design options, we're able to evaluate and estimate effectiveness of those different treatments before we make that final decision on which alternative or which option we might move forward with. And really importantly, if you're going to be applying for safety funds, the safety study really provides that means or that backup, that justification for the safety funding specific to the proposed countermeasures and the project that will move forward into the next stages of project development. So the procedure for safety studies, this really applies to all studies. The first is a start with identifying your problem and your goal. So typically speaking, when you're dealing with an ODOT study, this is going to be something that's identified either by an ODOT district or someone in the central office safety program, but it can also be something that's identified by an MPO or local government. But really what it needs to be is it needs to be an area of safety concern with a documented level of safety issue associated with the actual location. Once you identify your problem and the goal, what you're trying to essentially address, then it moves into that study area definition process. It's really important for us to capture the appropriate study area so that we have a fair comparison of the existing condition to any proposed improvements we might implement. And most importantly, the impacts, the direct safety impacts of those proposed improvements are important to capture. This all usually starts with a startup meeting with the district safety review team. The district safety review team is that multidisciplinary committee within ODOT that is going to guide and ultimately will serve to review and approve the recommendations of the safety study. It is something that coordination with the DSRT and most importantly, if you're an LPA or an MPO with that local safety coordinator is very, very critical at the beginning of the project, because that's how you're going to set the stage for the district safety team's support of the particular project as you move it forward and get it in front of ODOT for potential approval for some safety funding. The studies are often likely to recommend a minor PDP project. So because of that, as those of you familiar with the PDP process, the team that reviews this and is part of just the development of the safety study initial scope, and then also potentially folks that should be involved throughout the development of the safety study really should be multidisciplinary, so that it's a comprehensive study that once you define some potential improvements, there's also some appreciation of the extent of potential impacts, perhaps right of way, perhaps utility, maybe perhaps other things that you need to consider and need to put in front of ODOT as they make a decision on the safety funding. You can have and hold and should hold a startup meeting in cases of when this is for an LPA or even at an ODOT district project. This can serve as a kickoff meeting, with ODOT and the PDP process. And then as far as with MPOs, a lot of times this initial startup meeting, MPOs or local governments, involves that initial scoping step, and particularly the refinement of the scoping as well. What you're going to want to do when you're developing that scope is identifying if this is going to be a full or an abbreviated safety study, and this is determined generally by the ODOT district that you're involved with or that you will be involved with. Please do, always coordinate. If you're doing a project for ODOT, that coordination will start from the beginning. But if you're working from an MPO or a local public agency, this is another reason why it's really important to coordinate with ODOT, because you want to make sure that you understand if there's been any previous studies done before. And in certain cases, if there have been, then that might guide the actual scope in terms of whether it's a full or abbreviated study that ODOT really needs to see in order to move forward to make more decisions. You'll review with that team the study area. You'll then also request the crash data, or in this case, you won't really be requesting it. You have the access to it through ODOT's ODOT systems now, so pretty much anybody can get that crash data. But what you will want to do is confirm very early what years of data you need, because as we know, there's some reasons why in some areas we don't include certain parts of data and certain years of data. Right now, the COVID situation is a big one. In some areas, ODOT is suggesting that year of data 2020 be skipped. There also may be other reasons why you would provide, a different number of years of data in terms of the 3-year grouping. Perhaps there was a construction project in the vicinity of the area that you're going to study that could affect the crash data. So you need to have that kind of information, and you need to coordinate that with ODOT, in particular, just to confirm as you're starting that you have the right 3 years of data. And in some cases, up to 5 years of data might be used. There are 2 funding rounds every year. Now, I kind of changed this a little bit from our previous version. I want to make sure that it's really clear. Applications can be submitted on April 30th and September 30th, but the applications themselves and those dates should not be the first time the district reviews the safety study. So we're pretty familiar with this, and the district teams usually guide that pretty well if it's a district study that's being performed. But again, we share this for the MPOs and the LPAs and the consultants. Some of these projects, perhaps that are not on ODOT's safety priority list or are a local priority. The district review team needs to be involved early and often to provide the greatest chance of success in getting that safety funding, and they can't see it as of April 30th or September 30th for the first time. So like I mentioned, if seeking ODOT funds, contact the district safety coordinator to verify the level of effort and schedule for submitting that study and application. Another point to make, every district is different. So don't assume because you've done a study in District 12 that the schedule that District 12 follows is what the schedule is what District 7 might follow. It's really important that you talk to the specific safety coordinator at the district to make sure that you understand what that schedule needs to be. Typically, what we say is that the study should be received by the district at least 3 months prior to the application deadline to provide that time, enough time for
Cindy, I think we lost your audio.
and those submittal offices those submittal deadlines are really April 30th and September 30th, so you can see why we need to back up those dates. You can't be submitting it to district on those dates because that's when they need to turn it around to central office. So you need to back up at least a month ahead of time you're submitting your final study to district so that they can make sure, you know, all the T's are crossed and I's are dotted and they're comfortable with the recommendations. And then there's at least a couple months ahead of that that you should be coordinating at a minimum with district. You know, the important thing is consult early and often with district. All of the countermeasures that you're going to recommend in your studies for a given project must be also recommended, or i.e. endorsed by the DSRT and approved by the DSRT before it can go on to central office. So central office is not going to review anything that the DSRT hasn't, at the district level, hasn't reviewed and accepted. Now, that's not intended to be any sort of barrier on this. In fact, the district safety coordinator and the DSRT, they're very, very supportive of you know, both the state and the local agency submittals, and the competition is there's really not competition. The comparison, I guess, is very fair across the board. They have a great partnership with the local public agencies and encourage and really want to share their funding with local agencies. So it should be considered an opportunity to make sure that whatever recommendations come out of any study, you know, are supported by the DSRT. And that applies, that same, you know, that same recommendation applies also for any sort of studies you're doing for the district. The district safety coordinator is there for your support and your help with them throughout the study development process, because then when it gets to that review time, it's much easier for them to review and approve it, particularly if they're reviewing multiple applications at the same time. So let's continue a little bit more. You know, again, this is what we're going to touch on today. We're going to go through all of these steps between Alex and myself. We will hopefully hit every single one very thoroughly, and you will have, you know, you'll have a confidence level coming out of this course that you can develop a safety study that will be received well, you know, by district and by central office. So for a few additional points, we're going to go a little bit more into the district, you know, the district background, the highway safety contacts that you're going to want to use when you're doing the studies. If you're going to be asking about a specific location, that's something that gets directed to the highway safety coordinator, the district highway safety coordinator. We don't want you to go through to central office directly. It should always be through the district safety coordinator. But if you have general questions about the ODOT safety program, you can contact Michelle May. She's very happy to work with you. And then for questions regarding crash data and analysis, feel free to contact Derek Troyer. And to be honest with you, either of them are great contacts for any questions you might have. So you know, reach out to them directly, and if they can't address your question, someone else, they're going to point you to someone else that can. Another thing that I want to point out is throughout the course of this presentation, there will be links that are shown when appropriate at the bottom of the slides, and those are to provide you the links, the current link to the page where you can find this information. As you know, ODOT has made changes and updates to their website over the past several years. And sometimes we've bookmarked things and we go back and we try to find those locations and we can't. So we've tried to make sure that at least for at this snapshot and this point in time, the pages you see up on the screen and the things that we're talking about, you can find them fairly quickly. You might have to type them in if you, you know, unless you can convert that quickly to some text, like if you have the PDF, but at least you have that link and you can get straight to where you need to be. This is what the list of the district, the current list of highway safety coordinators looks like. So if you need to, if you can't quickly get online, these are the numbers and the folks that you're going to need to reach out to for safety studies at each of the districts. And now we're going to talk a little bit more about the program in general. So ODOT is a TZD partner, a Towards Zero Deaths partner. They are striving for zero deaths through their strategic highway safety plan. So what that means is ODOT's sole focus in safety is eliminating traffic fatalities and serious injuries on all Ohio roadways. ODOT has one of the largest safety programs in the U.S. with approximately $158 million dedicated annually for safety programs, and they use it. and they use it both on state programs, on local programs. It can be used for engineering improvements, basically to improve safety on any public roadway. And then ODOT also funds millions of dollars of systematic improvements annually, and then also invest a considerable amount of funding in education and enforcement programs that encourage safe driving. Every step you take might be something that you've heard of and is one of their marketing brands for their safety program. ODOT is fully invested in trying to eliminate traffic fatalities and injuries on their roadways, all roadways throughout Ohio. A little more background: Ohio's fatalities have technically or have traditionally trended down, for the past several decades, which is a real win. And in fact, in 2013, Ohio had 990 traffic fatalities, which is the lowest number of fatalities since 1936, when ODOT began maintaining, and shows the success of their safety program. However, from 2014 through 2019, those serious injuries continue to trend down, but fatalities have started to rise. And there's a lot of reasons, behind that. I mean, there's a lot of potential reasons that we don't know exactly why that is happening. But, part of it is, they've had a very successful program. So the investments that they've made have really had an impact, and they've taken some of those big heavy hitter issues out of play, and so they're seeing that impact. And so the ability and the effectiveness of some of their treatments the effectiveness has changed a little bit over time, which is natural. If you make progress towards reducing fatalities, that's a good thing. So you're going to see those trends change a little bit. But we do have a few other things at play. We have a lot of newer, safer vehicles. So what that means is the severity of crashes is going down. So, if you look at from that 2014 to 2019, the serious injuries, that's really a direct result in part because of the safer vehicles. But there is a side to that is an interesting point. Those safety features are also now currently being counteracted by some dangerous activities, such as extreme speed, not wearing seatbelts, and a big one, distracted driving, and also impairment by drugs and alcohol. So ODOT's implemented a lot of things to make their roadways safer. The automobile manufacturers have implemented a lot of things that have made the vehicle safer. But what is very difficult for ODOT to control, and any public agency, anybody, frankly, is the human side of things. And humans have started to and continue to pursue some very dangerous activities while they're driving, which is reflected in the fact that even though the cars are safer, when people do get in a crash that are involved in one of those activities, that potential for fatalities is out there, and it's very real. So why are we saying this? Well, this means it's even more critical that ODOT safety investments focus not only on preventing crashes, but also on reducing the severity of crashes when they do occur. We want to make sure that as engineers, planners, transportation professionals, when we're developing these safety studies, that we're thinking of countermeasures that are comprehensive and not just targeted at preventing and eliminating crashes, but also recognizing that when a crash occurs, we want that severity to be low. We prefer everybody to walk away with a property damage only crash. That right now, presently, is not realistic, but ODOT really believes that that we can get much closer to that point, and that's why they're working towards that effort to get to zero in terms of the fatalities and severe injuries. So our job is that much more challenging. We have to try to counteract the behavior of individuals, but we also want to make sure that we're building into our environment, into our roadway systems, treatments that not only prevent crashes, but also minimize the impact of crashes. So Ohio's Strategic Highway Safety Program, it is a comprehensive plan identifying, the causes of serious injuries. And this right here shows you the link to their portal, in essence, for their Strategic Highway Safety Plan. We encourage everybody to take a look at that Strategic Highway Safety Plan, because this is really the plan that drives ODOT's actions towards getting to that zero fatality and serious injury goal. And one of the methods that they have decided to use and elected to use to get them a little bit closer and to move them to that point where they can walk away and say, hey, we have done a great job and nobody's getting hurt on our roadways, is to use the Highway Safety Manual. The Highway Safety Manual is something that has come about over the past 10 to 15 years. It is providing some technical background on what we call the basic science of crashes. It gives you an overview and information on safety management methods and approaches. So it's helping, DOTs guide their safety management practices all the way from identification of priority locations through to the implementation and construction of projects. It gives us now some methodologies for predicting crashes. Why is this important? Because for many, many years, we had to use crash rates, which look back in order to get a sense of what a potential impact might be for an improvement. But as I think probably which comes to mind when you're thinking about it, how can you decide what's going to happen when you change something and make something new from information that's in the past that has to do with the old condition? Yeah, that was a challenge. So professionals in the industry understood that there was a lot of research out there on predicting crashes based on design elements, and why not get it and put it together in a resource and a reference document for transportation professionals, and that's what the HSM is. It also helps us understand those effects of treatments on crashes so that we can figure out when we implement something or something is implemented or we suggest something should be implemented in one of our safety studies, we can understand those potential effects and benefits. We also can understand the negative sides of those things as well when it comes to crashes. Sometimes we may implement something with the intent that we want to reduce, a certain type of crash, but the end result is it results in an increase in another kind of crash. That's the kind of information that we can get using the Highway Safety Manual. Overall safety is that top priority for ODOT, and the HSM is that tool that helps them make these really good and the best possible safety decisions. So this is something that you just need to be aware of. When ODOT decided to implement the Highway Safety Manual into their program, they had a very comprehensive plan. The good news is it is very effectively implemented throughout the majority of the program right now. And in fact, some of the history of the accomplishments that ODOT has in this implementation. In 2010, ODOT was one of the first states to use the HSM, and then also OHDOT Safety Analyst, which is based on the HSM, to prioritize and identify their locations, their 8 HSP priority locations, and that's for their studies and funding. In 2012, their HSM, and that you think about that, that's like 9 years ago. In 2012, HSM was incorporated into their Traffic Academy training. One of the things that I didn't specifically get a chance to do was give my background because of the glitch that we had. But just to give you a perspective of where I came from, I've been in transportation, traffic engineering, and highway safety for at least 20 years. And for the past 12 years, I've been working with folks that are implementing the Highway Safety Manual across the country. So I've been involved in the training and the HSM training almost since the beginning that ODOT has had, and ODOT has had training courses on the HSM and has been incorporating the Highway Safety Manual throughout their program for close to 10 years now, and I've been involved at least with the past 6 or 7. So this has been a really strong initiative for ODOT, and we've been doing this Traffic Academy training for quite some time, and pretty excited that it continues to grow. In 2013, ODOT built a single spreadsheet to automate the HSM calculations, alternative analyses, and benefit cost analyses. You'll know that is the ECAT tool. There's some industry tools that are out there that do the first point, those HSM calculations, but ODOT was the first really that I know of to incorporate that into a spreadsheet that was comprehensive, that allowed you to do alternative analysis and cost benefit analysis. So you could use it from start to finish when you're doing your analysis for a safety study. ODOT presently uses HSM throughout the transportation and design process. including right now, they're using it heavily in design exception process. Some of you who may be on the design side are familiar with that use as well. And they use it from scoring of HSIP funding applications, all the way through, like I said, to design and construction evaluation. So ODOT safety program priority locations, most of us are familiar with the lists that we've seen. ODOT, they focus on those sites that have the most potential to benefit from a safety improvement. So what they're doing is they're using the highway safety manual to estimate that potential for safety improvement. They look at screen all the locations on their system, identify based on using the highway safety manual's methods to predict crashes. They're able to determine, okay, based on the design that's out there, what would we predict that we should be seeing in terms of crashes, and then compare that to what's actually happening. So that's what they do in order to determine that potential for safety improvement at all of those locations. They think very positively about their program. There are locations that are identified as priorities, and those priorities are there because they know with the right improvements and the right treatments, there is a real potential to reduce crashes and future crashes. Now, in this case, I will tell you that this is one of the websites that's still currently under development. What you'll see up on the screen here is what most of you who do this are familiar with. This is what the old site looks like, and that old site is still active, that link, and they have all of their lists there at that old site that they're working from right now. And clearly, developing the future lists and the new lists have seen a challenge because of COVID. But there's also the new location that contains all of the new information on the program and the safety priority locations. But what is not there are their highway safety priority list, or at least they weren't there 2 days ago when we were looking at this. That information, I'm sure, will transfer over, and they will have that updated at some point in time in the future. But in the meantime, if you're looking for or wanting to confirm that you have the latest lists, definitely reach out to your district safety coordinator. But you can also, reach out to the folks at central office as well. My recommendation is always contact the district safety coordinator. Give them the first opportunity to give you that information that you need, but you can always CC or copy central office. And then that way they're in the loop as to what you're requesting. There is a highway safety maps location, and so you'll see the link below, but this is really kind of mapping out the safety and priority locations. You can do a lot of neat things. Obviously, ODOT has a really great GIS-based program for about everything when it comes to safety. So you can look up these maps and get them in the format that you need them. And then ODOT has a lot of highway safety manual implementation and training tools that you'll use throughout your development of a safety study. And Alex goes into a lot more detail in these in later modules. But this is just a list of the things that either ODOT or you might use. Safety analyst is something that ODOT uses, but then a lot of folks here are very familiar with GCAT, the GIS crash analysis tool, TIMS. Everybody, I think, accesses TIMS now that does work, whether it be design or planning level work with ODOT. The crash analysis module CAM tool is something that Alex is going to go into detail. It's the format that you get the crash data in when you download it, ultimately from ODOT's resources. And then the economic crash analysis tool, like we mentioned earlier, that's that comprehensive crash analysis, alternative analysis, benefit cost analysis tool that you use in developing safety studies or any safety analysis that you might do for ODOT. Again, we'll demonstrate several of these over, I don't want to say throughout the day, throughout the course, because we split this course into 4 days for you. So for the project development process and where the HSM and safety analysis applies, basically everywhere. And I want to say, just because it's not circled in construction doesn't mean that doesn't apply. It just happens that these particular list of details from construction didn't hone in on the area where the highway safety manual applies. But really, when you start a project, you want to analyze your alternatives. As you're going into preliminary engineering and into design, You need to use it to refine and identify key elements of the design. For environmental engineering, it can help you with the NEPA process and documenting the purpose and need, and also then documenting the choice of alternatives given the potential environmental impacts and other impacts. And then final engineering, it's also going to help you further design and refine design and do things like value engineering and those types of things. Now in construction, it does apply, because I want to point out here for those of you who are more on the design side, just because a project's in construction doesn't mean that you can't use or find a way to use the highway safety manual and the safety analysis. If there is a proposed change in construction that might affect design, it's very important that the design engineers and the construction engineers go back and verify the reason why the decisions were made during the planning and design process, because some of those decisions are influenced by the safety components and the safety aspects. And if you're going to change something when you get to the actual built environment, it very much could have an impact on safety performance and on what you might expect to happen at that site in the future. So that anybody who works in that area of the refinements, design refinements, when we get to the construction stage, should be aware that, you know, the HSM is definitely relevant and it's informative in helping you develop those next steps for making changes in construction. So again, where does it apply in the study process? It applies everywhere. The HSM applies, you know, when we're thinking about collecting data and diagnosing crash patterns. We definitely need to know what data we need in order to do analysis. So when we're collecting the data, we need to be aware. It helps us diagnose crash patterns. It's very helpful to see what might be expected to be, you know, at that site in terms of the distribution and types of crashes compared to what's actually happening. When you're getting to the point of identifying the potential for site safety improvements and possible countermeasures, it's giving you some hints and indications on the things that might be most effective. And then most importantly, it tells you what the effectiveness of those potential options are. When you're performing your relevant traffic studies, obviously you need to keep those in mind and the HSM in mind as to what you need in order to support the decisions that are being made based on safety. Evaluating countermeasures, similar to identifying potential and possible countermeasures. This is when you get to that final evaluation of your proposed improvements. And then finally, it's of course, it's woven throughout the development of the plan, the safety study, and finalizing the report. It's very critical that you keep the HSM in mind. It's a perfect tool for helping you quantify potential impacts, talk about those impacts, and the last module that we'll go over of this series, we'll talk a little bit more about how you can communicate things a little bit more effectively, and the HSM is a great tool for doing that as well. So before we go any further, I am going to pause for a minute and see if there have been any questions that have been submitted to this point that we potentially need to address before moving on to the next stage. And then I'm also going to get a quick drink of water. So Mike, Alex, are there any questions that we need to potentially go over yet?
Hi, Cindy. We did have one question, and Alex has responded to the question. So Alex, maybe you could talk about that.
Sure, thanks, Mike. So there was a question on safety funding and what exactly can be applied for. You know, the safety funds that Cindy was talking about initially in ODOT's greater program are really comprehensive in terms of plans, studies. There's definitely some research efforts in there too. In the context of safety studies and what the safety funding application is for, it really is for infrastructure, or primarily is for infrastructure-based projects. That's what we're applying for funding for. Within those infrastructure projects, there is cost for engineering, cost for right-of-way, cost for construction itself. So it is a comprehensive project funding, but it's primarily what we're talking about is funding projects.
Absolutely. Thank you, Alex.
Mm-hmm.
Okay, all right. Then I think I will continue on. Thank you. So what we're going to do is we're going to talk a little bit more about the Highway Safety Manual. I hope that folks by now are familiar with it and familiar with its use throughout ODOT's program. But I think it's still important for us to take a little bit of time just to provide that context to let people know why and why we're doing this. And the best way to do that is to go over the Highway Safety Manual and what it really provides to us as professionals. So why are we really talking about introducing a new methodology? And when we say new, it's really not new anymore in Ohio, but it still may be new possibly to some of the local public agencies, or a little more new to local public agencies, and for people who are doing the traditional type of analysis, which typically is based on crash rates. We're developing and using this newer methodology, the Highway Safety Manual, because it allows us to look at things even more comprehensively. There are really two dimensions of safety. So nominal safety is the safety that we understand as being examined in reference to compliance with standards, warrants, guidelines, design procedures, our location and design manual, the AASHTO Green Book, potentially even the MUTCD. There is a presumption of safety, associated with meeting a standard, a guideline, or a warrant. But then there's also this aspect of substantive safety. And substantive safety is really about the actual safety. So that's really taking into consideration that, there are nuances in safety. There's incremental changes in safety that we would expect in changes in different design. So what it considers that expected or actual crash frequency and severity for the highway or roadway that you're actually looking at based on, the volume, where it's located, the context of that particular design. And it allows us to get much more granular than down to just a simple yes or no, does something meet a standard or not? Why do we care about this? Because the two dimensions of safety really produce different outlooks. When you see it on paper and you see it this way, when you see it up on the screen, you can kind of appreciate it a little bit more. Traditionally, there is this presumption that, there is greater crash risk until you meet that design value. And so in essence, it would look somewhat like the green line. You're going along at a certain presumed level of crash risk, boom, you hit that point in time when you meet that design standard, and then you fall off that cliff and you don't have any crash risk, or have a lot less crash risk, moving forward. Well, that's not reality. The reality is there's a difference in crash risk between a 12-foot, an 11-foot, a 10-foot lane width, and we need to be able to understand that in order to design most effectively and most comprehensively formulated design for our proposed improvements that we hope actually results in that either short-term and long-term reduction in safety, or a reduction in crashes and improvement in safety. So a little bit more on that. Substantive safety is very context sensitive. So let's stop for a minute and think about the types and severity of crashes that we might expect at each of these locations. So the first location that you see on your screen is a rural 2-lane highway. It's winding through some different topography. The roadside edge, the road edge is different, as you can see, but depending upon where you are within this particular section of the roadway. So we would expect in this situation that we would see a lot of varying different types of crashes, but most likely the largest ones and the most predominant would be the roadway departure, the run off the road, lane departure, those types of crashes. We would also expect in this type of environment to see higher speed related crashes because these types of roadways typically have the higher speed limits because they're rural and they're in areas, in Ohio, we know that outside of certain municipal areas, there's actually, some Ohio revised code, there's some code requirements for the speeds, on roads like this. So we know that they tend to be in the higher side. And then typically speaking, if you were to see someone run off the road at a high speed on one of these types of roadway locations, you probably expect to see the severities a little bit higher than other locations, perhaps that have a lower speed and maybe don't have the same type of roadway environment. So clearly, you can see substantive safety and safety in general is very context sensitive. Now in this image, in this picture, it's a central business district in, a small town USA, small town Ohio. We're going to see completely different type of crash, patterns and severities than we did in that first picture. We're going to see things like backing crashes, vehicles backing out of those angled parking spots. We're going to see pedestrians. We're going to see potentially bikes. We're going to see, you know, a very different, even mix of vehicles, you know, in terms of how we might see it. And probably, you know, for the most part, maybe with the exception of those pedestrian and bike crashes, we're going to see a lot lower severity. We're going to see a lot more property damage only crashes when things happen, and a lot lower severity in terms of the impacts in the vehicular crashes. In this location, completely different story as well. In fact, I'm not really sure that we wouldn't see any type of crash out here. You know, it's probably in a busy area, but you can see it's a higher volume of roadway. It's a business area. It's kind of like retail commercial. So while we would hope certainly that the speed's 25, it's more likely to be along the lines of 35. So we're starting to move our speed up a little bit. You know, we have so much traffic. We have every single possible type of vehicle that you have a person walking across the middle of the street because there's no pedestrian crossing. I mean, we could just see about any type of crash out there possible. So you can see if you look at all three of these images, there's really a lot of difference between all three types, and safety therefore is very context sensitive. And what we have in the Highway Safety Manual is a tool that helps us appreciate that more, because it's not looking at things in terms of, you know, standards and whether or not we meet a lane width, because that bottom picture, that last picture may meet every single standard we have, but you could still, obviously, common sense tells you that we've got some serious safety concerns there that can't be captured simply through you know, an evaluation of whether or not that design meets standards. Again, you know, more information. Why do we care? Well, a good decision is an informed decision. And, you know, as engineers and planners and transportation professionals, we all appreciate that an informed decision really requires data. In fact, most of us are not comfortable in making solid design decisions unless we have some data to back it up. Yes, we use engineering judgment all the time, but typically engineering judgment is based on experience, and it's based on some sort of evaluation of data or information that we've had or used elsewhere. So again, an informed decision and a good decision really does require data. There's also this kind of implied level of importance. When you have more data and you have more detail and you can get more granular in your analysis, you really have this larger amount of comfort. And so then you kind of put, you know, a little bit more importance, a little bit more weight on that information when you're making decisions in order, you know, you would put a little more weight on those points that have more data. In the past, all we had for safety was crash rates and design standards. So looking, you know, historically and with the crash data itself, all we could do was look backwards. And as far as looking forwards, all we could do was look at design standards. And like we just talked about recently, you know, you could see that design standards don't tell us, they tell us something, but they don't tell us enough. And in fact, the reality is a lot of design standards are not based on safety as a primary decision point. We would hope and would have hoped that they were, but the reality is they weren't. And in fact, a lot of design standards are based on comfort or based on the ability, you know, for people to operate a vehicle comfortably, but not necessarily consideration of safety within the decision-making process. But as you look at this, kind of graph, you could see moving from left to right, you know, as we get further into the design process, we have more and more detail. We can get more and more focused in and honed in on the accuracy of things, and therefore there's an implied increase in the level of importance. So isn't it great that now we can get safety up to that point, at least to that point in the planning and decision-making process, that we can weigh it fairly and equally amongst all of those other planning and design tools that we have to currently help us make those design decisions. So some typical decisions that impact safety, aside from really saying that everything does, let's just think about it and break it down a little bit in more detail. So we use safety in the discussion of determining which projects to do and not to do. Frankly, you know, one of the elements that we consider, you know, is whether or not there's going to be an improvement or potentially a detriment to safety. So that really helps us make those decisions. When we're dealing with things like alignment and cross-section, you know, we want to make sure that, you know, what we're proposing makes the most sense in terms of safety as well. Intersection improvements, we often include or add turn lanes, we change our traffic control, we install things like roundabouts, and that allows us to, those are the things that involve or influence safety. Roadside improvements, where things are placed on the side of the roadway when someone leaves the roadway, thinking back to that picture that we had where we looked at the rural 2-lane, it sure does make a difference what's along the roadway in terms of whether a person who leaves that roadway might be able to recover and get back on the roadway, or will strike something that is an object and a potential safety concern. Traffic signals, permissive protected signal phasing versus protected only, right turns on red, access management. There's always that competing interest of allowing access and full access movements against the fact that people and cars are crossing in opposing directions, on busy roads. And so we're always discussing safety and weighing the positives and benefits and the negatives, and design exceptions themselves. We use that very frequently, and ODOT actually has a process in place. Quantitative tools do help us make informed decisions. We're used to using it in things like in planning, like the trip generation manual or the traffic noise model. When we're doing our environmental impacts, we can use the highway capacity manual the same way in that early stages and throughout all of project development, because it really provides us with some models that we can use of traffic operations for all types of facilities. Sorry, the highway capacity manual allows us to do that. It gives us the statistical models of traffic operations of all types of facilities. And the HSM is a similar tool that gives us models that allow us to predict safety performance and crash rates for our facilities. So we can use this as a quantitative tool to help us make those informed decisions. It kind of probably makes sense if I tell you that the highway safety manual was intended to be something like the highway capacity manual. It's, in fact, the folks who generated the idea for the highway safety manual were sitting around a table at a national conference on transportation and said, hey, we really need something like the highway capacity manual for safety. We need something that is a resource that summarizes all of the best research in safety, provides some general guidance on how to use that research to evaluate safety performance and how to use that research throughout the project and development process and through planning and program management, and something that takes the best of the best research and puts it forth for use by the transportation industry. There's a lot of research that's out there, not all of it's great. So they recognize that there needed to be this one kind of compendium, this summary guidance document that transportation professionals could use, just like they were using the highway capacity manual. The highway safety manual is a synthesis, like I mentioned, of previous research. There was some new research that was commissioned by AASHTO and FHWA, and it's good to know some of Ohio data was used in multiple research topics that have been included and are included in the research in the highway safety manual. So we're represented within that research. Why are we doing this, and why are we moving away from and not using crash rate? Well, we mentioned earlier, adherence to design criteria really does tell us nothing about safety performance. There's no way those manuals themselves figure out what the impact on safety performance is going to be by changes in our design. Crash rate as a benchmark for decisions is really not correct. We know volume effects are nonlinear, so crash rate bias favors lower volume roads because of that. So it's just one of those things that we've got to do better, and the HSM allows us to do better. And we see a big difference in estimating expected crashes because we know that they vary by number of lanes for the same highway type. It's not just that they differ by the highway type itself, like we were talking about in the context sensitive discussion, it also differs by the number of lanes for the same highway type. So there's a whole bunch of other reasons we can name why crash rates aren't correct and aren't the best tool. It doesn't mean that there isn't a place for crash rates. Crash rates are very, very useful when they're applied in the right context. If you're looking at a roadway and comparing roadways of similar types and crash rates for roadways of similar types, it provides a very good tool for gauging just a general approximation. But really, what you can't do, that's looking backwards, that's saying, okay, I understand what has happened. You really can't take those and move those forwards into the future very well. Because you have to have, if that's the case, you would have to have a crash rate from a facility that is exactly like yours, because we talked earlier about the context sensitivity. It would be exactly like yours, and that just doesn't happen. We just don't develop crash rates using that type of approach because we don't have enough sites of enough diversity and enough grouping by diversity in order to be able to develop those kinds of differing crash rates. For the HSM and the science of safety, so this new concept and understanding of crashes in the HSM allows us to understand that focusing on crash frequency and expected use of best practices. We'll talk about that a little bit more later, but really it just boils down to we only typically look at 3 to 5 years of data. That may not be the right representation for what we want to see in terms of a long-term performance of the location that we're looking at, and so it's really difficult to make really good data, decisions based on that kind of information. The Highway Safety Manual does break things down by things like single vehicle, multi-vehicle, pedestrian, looks at things by safety, it looks at things by crash type. That's the information that we need when we're particularly trying to target improvements that have the biggest potential to benefit safety. And then, with the Highway Safety Manual, it allows us to predict crashes based on our actions and the changes that we propose. And, we do this because we can use research that is based on proven effects of roadway geometry and dimensions on crash frequency changes. And so therefore we can use that to help us do evaluation of what we might propose as a future improvement. Not all improvements that we do are based on a safety need. Sometimes there's other needs that we use in order to identify an improvement and propose an improvement. It's really helpful to understand that if we're making a decision because of another need, will it also have an effect on safety, and what will that safety effect be, so that we can do the best we can in proposing improvements that are comprehensive and hopefully don't have a negative impact on safety. We can't always guarantee something's not going to have a negative impact on safety, because there's a lot of reasons, very important reasons, why we make our decisions as engineers, but crash frequency is the basic measure of crashes that we use in the HSM, and it's usually typically in the number of crashes per year. And it's most frequently expressed for a location or site. So comprehensively, if we're looking at a project, we would be able to estimate crashes per year for that entire project area, but we can also estimate crashes per year for individual components. It could be intersections, it could be segments, it could be subsections, within our project area. We could do all different ways of looking at it, so we can identify when there are safety issues, what is the true safety, the source of that issue, and then or what we suspect the true source of that issue might be, and then it can help us really nail down where we want to focus our improvements at. Sometimes we do represent things in a per mile basis to help us provide perspective. This is sometimes helpful when we're dealing with segments, and sometimes really helpful when we're dealing with like ramp segments, because different ramps, depending upon the length, may have completely different crash frequencies in terms of total because of the length. But when we are looking and comparing those things, what we really need to do is relate them back to a common variable, and sometimes that common variable is per mile, or the length of the individual segment that we're looking at. So there are 4 parts to the HSM, part A, B, C, and D. Each part brings value to the work of transportation professionals. The first edition of the Highway Safety Manual does have 17 chapters and 3 volumes. And then we have 2 more chapters that were introduced, 2 more chapters, I think. And then there were introduced 2 more primary chapters that were introduced in a supplement issued in 2014. In Part A, it's really the first 3 chapters of the first volume of the Highway Safety Manual, and it covers in general human factors and safety fundamentals. There have been some other documents and other resource documents that have been developed as complementary documents for the Highway Safety Manual with regards to human factors, but the HSM does provide an overview of the human factors component in the first 3 chapters. One of the big things, I think we alluded to it, or I alluded to it earlier, and we talked about it briefly earlier, is this relationship between the roadway and the driver and the vehicle. And this is an interesting diagram that is just something to give you food for thought and to contemplate. You know, it's something that is in the Highway Safety Manual, and not the actual graphic itself, but the concept is really about thinking about how things have changed over time. If you look at this is based on data from 1979. It shows the relationship of the roadway to the vehicle to the driver. Now, if we think about this a little bit and we pause and we think, how might this have changed? And the proportions of these different aspects in terms of contributing to a crash, we would probably expect that the relationship of the vehicle to a crash has gone down. We know that there have been a significant amount of changes in vehicle safety since 1979. Every vehicle now that's produced has an airbag in it. Every vehicle now that's produced has seatbelts. Almost every vehicle, but they should, has seatbelts unless it's a special situation. So we've got you know, a lot of difference in the safety of vehicles. Safety of roadways, same thing. I mean, we got to think about the way roadways were built. And the original system that was in place in 1979 was built for, one, a different series of vehicles that went a lot slower and had a lot different operational characteristics. It was built, you know, for a different set of guidance in terms of speeds. I mean, our roadway system was considerably different back in 1979 than it is now. We've made considerable improvements in the roadway environment. And think of safety in our roadway design. Instead of just moving a lot of people around, we want to make sure we can move them around safely. But what hasn't gotten better and what hasn't gone down is actually the driver's contribution, or what have, you know, the people part, the human factors, the human behavior. All of us have radios in the car. All of us have, you know, likely have a cell phone in the car with us. I'm hoping that the majority of us have made a commitment to put that cell phone down, turn it off, and not use it while we're driving. You know, that is the best way to handle having a cell phone, is just to turn it off completely. So that it's not a distraction, but the reality is it's still there. A lot of us use, you know, the hands-free options, but that's still, you're still distracted when you're doing and having a conversation and you're not paying 100% attention on what you're doing and what you're driving. Some of us eat while we are driving. A lot of us have a lot newer, fancier cars that drive a lot faster. So we do things a little bit more recklessly than perhaps we would have in the past. There are a lot of good things, you know, in our cars and in our environment. There are also a lot of distractions and a lot of things that we didn't have, you know, 30 to 40 years ago. Let's just put it that way. We just didn't have that there. So our driver component is much, much bigger. What does this mean to us? Again, we're not just looking at doing things to prevent crashes. We're looking at things to minimize crashes and also mitigate and make the severity a lot less. We also need to be thinking about design that works for our driver. If you think about that third picture that we looked at in context, if you were driving down that third picture of that road, be something that we influence in design. Is, are we designing a roadway environment? It's not just about getting the design down on paper that meets the design criteria. It's about stepping back as engineers, planners, and designers and saying, are we doing anything that could potentially influence the behavior of the driver? You can put a perfectly fine roadway down that meets all design criteria, and still there could be elements in that design that could be done better, that could be done in a way that wouldn't distract drivers or could give drivers a lot more positive reinforcement in terms of how they're navigating through their environment. So it's just something to think about. It's not enough just to put that design down on paper and say it meets design exceptions. We all have an obligation to step back and say, could I drive that corridor? Could I drive that intersection? And would I feel comfortable? And would everything make sense to me? Because that's very important, very important. So in Part B of the roadway safety management process, there are 4 chapters, chapters 4 through 9. This is the area that's primarily covered by Michelle and Derek's office. It's the network screening from a network system perspective. It's some of that diagnosis and countermeasure selection from that system-wide implementation perspective. It guides that economic appraisal and prioritization, the STIP and those kinds of things when they're actually looking at their program in general. The roadway safety management process contributes to that. And then also after everything's done and complete and they've implemented, treatments, they are still obligated to go back. And in order to continue to get federal funds in safety, they're obligated to go back and evaluate whether or not their program's been effective. And so that is what's covered, by Michelle's group. In particular, have utilized a tool called Safety Analyst. And what that tool did was use basic principles of the Highway Safety Manual to predict what they would anticipate their roadway environment safety performance would look like based on the design conditions that they knew existed on the system, and then compare that to what was actually happening. We didn't have that tool prior to 2010. And it really helped us dial in on the locations that we needed to study the most. So it reduced the number of manual studies in that period shortly between 2010 and 2013 to on average 600 per year to 300 per year. But what in turn it did was greatly increase the identification of sites with the highest potential for safety improvement. So what we were doing is we were not only doing fewer studies, we were hitting more of the high fatality, of the high severity, of the crash locations within that 300 than we ever did before at the 600 studies per year. So it was a pretty cool effect. It was really a great impact by the implementation of Safety Analyst, and they've been using that ever since. And so you can see if you spend some time after, really looking at these graphs and see what they're saying, it really says, Safety Analyst was really a great tool to help ODOT hone in on where they needed to treat for safety the most on the system. So Part C is actually the entirety of the second volume of the HSM, and it also includes that supplement that I mentioned. What's in Part C is that predictive methodology, those tools that we have to help us in the planning and the design. So we have safety performance functions, which are models to predict crashes. We have some crash modification factors, which in the context of the Part C, what those are, and I will edition of the Highway Safety Manual that's going to be coming out in a couple years. They're probably going to change this reference and how this is termed in Part C, but what that really means is, if we have a model that tells us what, our site might look like under a certain set of generic conditions, those crash modifications help us change the results of that model to what is a little closer to what we actually have. So that's what the predictive methodology allows us to do. Also covered in the predictive methodology is how states can calibrate what's in the Highway Safety Manual to their own state. It goes over several applications, and then the Economic Crash Analysis Tool, ECAT, is basically based on Part C and includes all of the models from Part C. In Volume 2, which is that second volume of the Highway Safety Manual, there are 3 basic roadway types covered. There's the rural 2-lane, rural multi-lane, and the urban and suburban arterial type roadway system. And then in that 2014 supplement I've referred to, there's also 2 additional chapters, which are Chapter 18 on freeways and basically freeway segments, and then Chapter 19 on ramps. And that includes freeway ramps and then the ramp terminal intersections. And so these are really helpful tools and helpful chapters that allow us to do a considerable amount of evaluation of proposed design and improvements when we're doing our job here for the DOT and other local agencies. In Part C, there is an appendix, and that's the common procedure, location of common procedures for all 3 chapters, plus the freeway and interchanges. In there, we learn about calibrating those to your specific jurisdiction, and then also this empirical Bayes process, which is really the analysis process that is the behind the screens analysis process used for predicting crashes. ECAT does include analysis methods, these chapters that I just talked about, and also take some select components of that HSM Part B, the roadway management process, for the benefit cost analysis that's used in the ECAT tool, and that's incorporated as well. So the HSM uses statistical methods for obtaining reliable estimates of crash frequency. Where can we use this? Well, we can use it at existing locations. It helps us determine how well the location performed compared to what we would expect. And it also allows us to look at proposed and future design projects, to how the project might perform, assuming it's designed and constructed, and I would say properly, but I would say comprehensively as well. So what do we get out of the HSM? We are able to estimate expected average crash frequency, which is associated with a particular geometric design, given time period, and specific traffic volume. It's very, very common. Mathematical models based on high quality data from multiple states. It controls what is called a regression to the mean bias, and we're going to talk about that here in a minute. It helps establish predictive relationships between a particular roadway type, like a rural 2-lane, and the different design components: lane width, shoulder type, offset to potentially obstacles on the side of the road, if there's lighting or no lighting, for intersections, if there's turn lanes, if there's a protective, signal facing for left turns, if they're right turn lanes. Those kinds of things are what we're able to see with this predictive relationships that we have in the HSM. And then it also incorporates that relationship of traffic volume to crash frequency. In most cases, it's a curvilinear, it's a logarithmic or type, it's a curve. But in many cases, in a couple cases, it still is linear. There are a couple cases where it's linear. How they do it is through these concepts that you'll see here, and you'll hear a lot about if you go into the HSM. Safety performance functions, those are the basic models that tell you if I'm going to have a rural 2-lane roadway, where do I start with in terms of prediction based on the volume that I have on my particular section. Now, it does assume some generic other criteria. For example, for a rural 2-lane, it might be 12-foot lanes with 6-foot paved shoulders, no roadway lighting. That would be the condition that you would get, your results for out of your safety performance function. But what if you need to know what that predicted safety might be for that type of roadway, but you've got 11-foot lanes and 2-foot gravel shoulders? Well, that's where these crash modification factors come into play in the HSM Part C. That's how we get from that base model output to something that's as close to ours as we can, our location as we can, with the information that we have and what's available in the predictive models in HSM. Calibration, it talks about calibration, specific to the state, and then incorporating observed crashes. So that's where that empirical Bayes term comes in, and we'll go over it here. So this is what a basic safety performance function might look like. In this case, a rural 2-lane segment. This is what we might see in terms of if we were to plot the line that comes out of, the results of different volumes input into the safety performance function. But really what it was and how it was developed is they collected data from multiple sites, they plotted them, and that safety performance function is that best fit line that fits all of the locations that they collected the data for when they were doing the research. It is used to express expected average crash frequency for a base condition, but it's the product of a statistical modeling process. There are separate models and functions for the different roadway types, road segments versus intersections, and even types of intersections. We can get data and output in terms different crash severities and combinations of crash severities. And the base conditions that are in the HSM were those that were established in the modeling process. And then the CMFs are the independent variables that they identified, that actually influenced and impacted safety for the specific roadway type. The crash modification factors, again, what they're used for is to express a change in the crashes when a factor or element's different from the base conditions. Like I said, 11-foot lanes. This would give you an example of what, how you might get that CMF value and what you would end up being able to use to convert from something like a 12-foot lane to an 11-foot lane. And then this is the basic, kind of the basic form of how the CMFs are applied. You have your predicted base model output. You have, which is this, based on that safety performance function or that equation for the base model. And then you apply all of the applicable CMFs that you can in order to take it from, that base output to what's something that's closer to your site. And then of course, if you can calibrate it, you want to calibrate it for the specific state that you're in. So the Part C CMFs that we talk about, those crash adjustments that you make from the base model to your site, those are actually why they're called that and why they're incorporated into this, into those chapters, is because those actual values were derived from the same modeling effort as the safety performance function. So for those of you who understand that a little bit, those were the independent variables, like I mentioned before, that they identified associated with the safety performance function that also influence safety. So if you change lane width, they knew, for all of the site types, changing lane width influenced safety. So that's one of the CMFs that you can use. You can change from, the different lane widths within your roadway types. But each of them, each of those series of CMFs is different based on the site type. So you can't assume that, for example, if driveway density impacts one, that it's going to impact another, or it's going to impact, even if it impacts another, that it would the same way, because all of them were developed independently based on data for that particular roadway type. So they can only be applied in that same setting. So if you get a CMF from Chapter 10, which is rural 2-lane, and you know that it has something to do with vertical grade or horizontal curve, you can't use those same CMFs to the other roadway types. You have to look within those chapters and find the CMFs that are applicable to those models and use those. And they're not always the same. You can only apply them, or you should only apply them within the ADT range included in the underlying model. The good news is for the tools that you'll use, ECAT, that's flagged for you if your volume range for the site that you're analyzing falls outside of that. And then there's even some guidance in the ECAT tool as to what to do if it does. If it's close, you can use the model. If it's not, then you talk to ODOT. That's a simple answer. And then those CMFs only apply for the crash type and severity addressed by the CMF. Again, something that should be self-explanatory, or should be something that you would understand if you're using it into the deep parts of the ECAT tool when you're doing your analysis. And Alex will go over more of that in later modules. So for calibration, all of the safety performance functions have calibration factors that can be developed because these SPFs and associated CMFs were developed from many different states' databases. In fact, the most predominant were Washington, California, and Maine. If you look at those 3 states and you think about Ohio, we're not like any 3 of them exactly. We probably have similarities with roads from all of them in some cases, and perhaps for some of our roadways in no cases. So we need to calibrate what was produced based on these analyses in order to make sure we can get as close to what we're getting, what we would expect to see on our system. Relative comparisons are still possible if you don't have a calibrated model. So if there's any consultants here that actually might work outside of Ohio and want to apply the highway safety manual, you can still use it. You just have to understand that those models aren't calibrated. And so what you'd want to do is you'd want to use it in terms of comparing 2 different conditions instead of trying to capture what exactly the predicted crash frequency would be. But it's still very useful to determine, say, if I'm going to go out and I'm going to change this rural 2-lane and I'm going to take, the 10-foot lanes up to 12-foot lanes, what kind of order magnitude change might I expect to see? And that's still very, very helpful. And it's better information than having no information at all in terms of helping you make your decisions. But ODOT, don't worry, ODOT has actually calibrated all of their models. And so you don't really have to worry about that if you're working in Ohio. But we're talking about models. But the reality is crashes and sites are still unique, and we probably can't capture everything that might be specific or unique about our sites within the results of those models. So what about the observed crash frequency? Don't we use that in our analysis? Absolutely. Yes, we do. But why do we use both models and our crash data? Well, it's because there is a bit of a bias that exists when only crash history is used. So we want to use what ODOT wants to use is they want to use that combination. They want to use a combination of the model output and also our historical site data to come up with a value that allows us to evaluate that site considering not only our site, but a bunch of other sites like ours, so we can get the best results possible. But why do we do this? Because traditionally we've only used like the 3 to 5 years of data, but there's a bias, there's a regression to the mean bias when only crash history is used. We only have 3 years of data. So let's say we were looking at those kind of funky green data points that you see on the screen, those middle ones that say site selected for treatment due to short-term trend. We are looking at a site often in these types of terms. We see a short-term trend. We try to identify something that could address perhaps that trend, which is an increase in crashes. But do we really know if over time we would have seen a continuation in that trend, or if that was just a 1 or 2 year fluke? Well, that's what happens. That's the issue that we deal with when we're only using that 3 to 5 years of data. We might not be able to capture what the actual average crash frequency is for that site over a longer period of time, and we might make poor decisions or uninformed decisions. We might perceive an effectiveness of a treatment is more than it is because we only are basing it on short-term observations of crash data. So in this case, if the green were the before and the pink were the after, we might think, wow, if whatever we implemented between the green and the pink really did a great job, of reducing crashes. But the reality is we don't know based on only 3 years of data. Why do we use HSM? Because that's where we get the more years of data. We may not be able to have it for our site, but we can have it based on a bunch of other sites like ours. So then that's going to give us that information that we need to make that informed decision. So the process by which that's done is called site-specific empirical Bayes. So that's going to reduce that effects of the regression to the mean bias. It's going to improve the crash frequency estimate. In this case, though, you do need a site type from the HSM to make that to work. I mean, that's probably common sense. You need that model, and you need to be able to have that model to estimate what our site is like, in other cases. But you also need crash data for our site, because what it does is it combines the results of the model with the actual crash data from the site in order to be able to estimate what that expected value might be, for our actual site. And then weighting, what it does, we do weight, based on the strength of the model. We combine those two values based on that. The weighting actually uses some statistical process that says based on the strength of the model, we're going to either emphasize more from the predicted or more from the observed, but basically that's all accounted for in the HSM process. And that'll be something we go over in more detail over the next few days. But moving past that into the last part of the HSM is Part D, the crash modification factors component. And this is different than the Part C CMFs. This section and this process and this procedure is essentially what you're more familiar with. Once you have an estimate of crashes at your site, in this case, we're going to use an estimate when we can of output from the model and our actual crash data. Then what happens when we actually implement something? That's what Part D covers, is that crash modification process. And that includes a lot more crash modification factors than we had in Part C, because Part C, they're only associated with the ones developed with the model. Part D includes everything else that's been done in terms of research that is sound research and quality research. So this includes a bunch of different information, but also what's not referenced, but we know from practice now, we also have FHWA, who's produced a crash modification clearinghouse, which is a searchable database. So Part D and Part C CMFs, select ones for that, and the CMF clearinghouse are included in ECAT. But I think the good thing is all of the Part D, if you're going to look in that third volume, which is Part D of the HSM, all of those CMFs are also in the CMF clearinghouse. So if you're familiar with how to use the CMF clearinghouse, that's a better place to go. But frankly, ECAT already has pulled out the ones, or ODOT's already pulled out, sorry, the ones that they would like you to use, and they're already in ECAT. So real quick conclusion. So why are we so interested in the Highway Safety Manual, and why do we go through it today for those of you who are unfamiliar? Well, the Highway Safety Manual is going to be that tool that form decisions on expected effects of crashes, effects of actions on crashes, changes in design on crashes. The key here is just reiterate, it's not a manual. It's a design guidance document. It's not, there's no warrants. It's just a tool like the Highway Capacity Manual to help you make decisions. And really, it doesn't make any of those decisions for you. And it's important to note, safety is often not the only decision point that you're looking at. So you're still required to take the information from the Highway Safety Manual and use it as part of one of those data points moving forward. It is, the development of the Highway Safety Manual 2 is in process or underway. It's going to incorporate relevant ongoing and other research completed since the completion of the HSM1. And we're expecting that it's going to be released within the next few years. And ODOT is already in the process of thinking about how they're going to be incorporating the results of that analysis into their analysis tools. And you will probably get to see their tools, ODOT's tools, updated ahead of the release of the Highway Safety Manual 2, because ODOT likes to get ahead of those things and wants to be on top of them to get the best analysis process out of their process. So we right there have reached the end of Module 1. As soon as I'm done here, we'll pause and we'll look to see if we have any additional questions. But just a reminder, there are 3 more modules. The first one's tomorrow, the same time as today. And then the 3 and 4, modules 3 and 4 will be next week on Thursday and Friday at this time as well. Thank you very much for taking the time with us today. We appreciate it, and we're excited to have you here with us. But we'll stop for a minute, and I see there is one question. And I see that the question is, since Ohio is implementing the CAV and smart mobility corridors, can we apply for funds from ODOT?
Cindy?
Yes.
That was the first question I'd already answered.
Did you?
So
okay.
I answered that one during the first question break that we took.
Okay, there we go. All right, so never mind, there's no more new questions.
But if I could real quick, I know, thank you, Cindy, for making up time. I know that this was, it's a lot of information being thrown at folks, but I can assure you, we touch on these repeatedly, these topics over the next couple of modules. The purpose is not to throw everything all at you all at once, but to introduce it and then revisit it with examples and really massage the information into a lot of different forms. So if you feel like you're drinking from a fire hose right now, don't worry, we go back and kind of make this more and more palatable as the modules go on.
Yes, and we alternate presenters for that reason, largely because next week or in between now and tomorrow, when you're thinking about the presentation material that I presented today, I'll be available to answer any questions as well on the side through this chat box that you might have. And you're welcome to send, we can pause now for a few minutes, or I guess 30 seconds or so, to see if there's any additional questions that anybody might have. But and even as a follow-up, if you have questions, please don't hesitate. In the case of this particular training, Derek Troyer is the right guy to reach out to. So if you have any follow-on questions today, I think that you're welcome to reach out to him as well.
All right, well, at the moment, we don't have any additional questions. So thanks, Cindy and Alex, for presenting today. And we look forward to part 2 of this series tomorrow morning. So thanks, everybody, for attending.
Thank you very much.